All right, today we're going to crack open a math concept that seems super simple on the surface, but it's actually a huge stumbling block for so many students. We're talking about the rational number. And trust me, it's way more than just a fraction. It's this core idea that if you don't quite get it, can cause headaches for years. So let's dive in.
I mean, think back to your own math classes, right? Was there ever that one topic that just didn't click? For a lot of us, that big leap from just, counting numbers to the whole world of fractions and decimals, that was a massive hurdle. And it's not just about getting a problem wrong here and there. It goes deeper. It's about a fundamental misunderstanding. And believe me, the numbers totally back this up.
Okay, so check this out. One study found that a staggering 82.2% of seventh graders were making mistakes when trying to actually use rational numbers and decimals. I mean, 82%. That's almost everyone. This tells you right away, this isn't just a few kids struggling. It's a huge, widespread problem.
And here's the thing. These aren't just random, careless mistakes. Nope. We're seeing consistent patterns of errors. And when you see a pattern, it points to something way deeper. It's a sign of a real, fundamental misunderstanding of the whole concept.
So the research we're looking at has a specific name for this, a misconception. And a misconception isn't just a simple slip-up, like an oops moment. It's when a student has a flawed idea that they use over and over again. And get this, they'll often even defend their logic if you ask them why they did it that way. It's a genuine, but totally incorrect way of thinking.
So, to really get to the bottom of why these mix-ups happen, we kind of need to take a step back. We need to ask, why do we even have all these different types of numbers anyway? See, our number system didn't just appear out of nowhere fully formed. It grew, it evolved to solve new kinds of problems. And understanding that journey, well, that's the key.
And this journey is pretty cool to see. You start with something simple, like x plus 2 equals 13. Easy, right? The answer is 11. That's a natural counting number. No problem. But then, what about x plus 5 equals 5? Well, to solve that, you need the number 0. And boom, now we have whole numbers. Okay, let's get trickier. X plus 18 equals 5. Uh-oh. To get the answer, you have to invent negative numbers. Hello, integers! But then you hit a wall with something like 2x equals 3. None of the numbers we have so far can solve this. We need a whole new tool in our toolbox. And that new tool is the rational number. So what is it, really? The official definition is any number you can write as a fraction, p over q, where p and q are both integers. And here's the super important rule. Q, the number on the bottom, can never be 0. That one simple definition, it just blows the doors open to a whole new level of math. But of course, a new level of math means new ways to get confused. So now, let's get right to the heart of it. We're going to tackle some of the most common misconceptions head-on, using actual examples of student thinking from the study.
Okay, take a look at this one. A student was asked if the statement, every integer is a rational number, is true or false. They said false. And their explanation was, because the rational numbers can be minus or plus. And you can almost see their train of thought, right? They've correctly picked up that rational numbers can be positive or negative, but they've completely missed the bigger picture.
The truth is, integers are actually a part of the rational number family. They're a subset. It's kind of like this. All squares are rectangles, right? But not all rectangles are squares. It's the exact same idea here. Every single integer is a rational number, but not all rational numbers are integers, like 1/2, for example.
And the proof? It's actually super simple. You can take any integer, say 5, and just write it as 5 over 1. Or take -3. That's just -3 over 1. Since you can write them in that p over q fraction format, they fit the definition of a rational number perfectly. It's this simple, crucial connection that so many students just don't make.
All right, here's another classic mix-up, turning fractions into decimals. When a student was asked how they did it, they said this. They're trying to follow a rule, but it's just the wrong rule. It's like they've invented their own little shortcut that feels logical, but in reality, it just doesn't work at all. So what this student did was turn 3/4 into 3.4. But here's the secret. A fraction is just a division problem in disguise. That little line between the 3 and the 4, it literally means divided by. So to do it right, you have to actually do the division.
3 divided by 4, and that gets you 0.75. Totally different, right?
You know, all these abstract rules can be really tricky to remember. Sometimes the best way to really get numbers is to just see where they live. Putting them on a number line can make things click in a whole new way.
So, here's a number line with just the integers on it. It's nice and neat, very predictable, but look closer. Look at all that empty space between 0 and 1, or between -1 and -2. It just feels kind of empty, doesn't it? Incomplete?
Okay, now watch this. Let's add the rational numbers to the mix. And boom, suddenly all that empty space starts to fill up. Numbers like 1/2, 1/4, -3/4, they all find a home right there on the line. This is what we mean when we say rational numbers make the number line much more dense. And this leads to a property that is seriously mind-blowing. Pick any two rational numbers on that line, I don't care how close together they are, you can always find another rational number squeezed in between them. In fact, you can find an infinite number of them. The number line isn't just full, it's absolutely, completely packed.
Okay, so we've seen the problem, we've looked at how it's supposed to work. But why is it such a big deal? Why does getting this right matter so much in the long run? Because I promise you, it's about way more than just passing a math test.
First off, understanding rational numbers is the absolute foundation for algebra and pretty much all higher math. Getting this right builds what experts call number sense. It's like an intuition, a feel for how numbers work together. And if these early misconceptions don't get fixed, they can harden over time and become huge roadblocks to learning down the line. So what can we do about it? Well, the study actually gives a really clear recommendation. We have to go beyond just memorizing abstract rules. Using hands-on materials, showing numbers in all their different forms, as fractions, as decimals, on a number line, all of that helps build a much deeper, more flexible understanding that actually sticks.
And that really leaves us with one last big question. You know, it's one thing to fix these mistakes after they've already happened, but how can we change the way we teach math to stop these misconceptions from even forming in the first place? And that's a challenge not just for teachers, but for all of us. For anyone who wants to make learning stick,